Alright, let's complete our lower airway anatomy. Remember, we just got done talking about it. I made a quick video talking about the upper portion of the lower airway. Now we're getting all the way through all these bronchioles and terminal bronchioles, respiratory bronchioles. Hang on, let me set my clock here so I need to keep a clock. Reset, start, there we go. I need to keep a clock to keep me on task. So these alveoli, we're going to make this that color. The alveoli are contained in alveolar sacs. So you have your individual alveoli, but they're contained in these big bunches. And you'll read that they mimic bunches of grapes. And if you can, think that if we cut one in half, about something like this. So we're looking at the back wall of, and obviously these aren't perfect circles, but that's pretty good. So now we have approximately 3 million alveoli, so 150 million per lung. It's an incredible amount. It's a heck of a lot. And they're grouped in sacs, and these alveoli are covered in a network of capillaries. And the capillaries help us do the gas exchange. So the alveoli is where the gas exchange happens. Air moves into the CO2 moves into the alveoli. Oxygen moves out and into the blood vessels. And there's this whole big network, this bed of of capillaries over the outside of each alveolar sac. Those are my drawings of that. And a real quick rundown. So capillaries are very thin. Capillaries are incredibly thin. They're the smallest blood vessels you have. And so we have veins, venules, capillaries, arterioles, and then arteries. Right. So that's just kind of how those go. We'll put that in parentheses. Some important things to know about the alveoli is that they're walls. So this would be like a wall. They contain elastic tissue that help the alveoli. Now, if you remember from previous videos, the alveoli, or the lungs, want to naturally collapse, right? The pressure generated inside the chest helps keep them inflated. But they naturally, in their natural state, without that, they would collapse. And that's one of the biggest issues if we get any trauma to someone's chest, is that if air starts leaking in, it can cause our lungs to collapse. And the reason they collapse, part of it is because they've got this elastic tissue inside of the walls of the alveoli. A condition known as emphysema destroys walls. And with it, the elasticity. And so what you'll get is you'll get collapsed alveoli. If your alveoli collapse, you have to breathe, and these people will do what we call PEEP. Peak end expiratory pressure, where as they exhale, they actually exhale through their pursed lips. And that forces negative pressure inside their chest to keep their collapsing alveoli popped open. And this pursed lips breathing is very exhausting. But these people have to do it to keep them from collapsing. So that's the elasticity, right? So the elastic. They also secrete surfactant. And surfactant is kind of like an oily, it's got lipids in it, phospholipids and all that oily And the purpose of surfactant is to help keeps the alveoli open. And I'll explain why. I'm going to do this really quick because this is kind of a wormhole you can go down. So inside your alveoli, you have a thin layer of water on the walls of your alveoli. Very thin layer. And the surfactant, its job is to go on top of, is to cover this layer very thinly, but it covers it. And the reason it does that is because water has some interesting chemical properties to it. And you can look this up on your own. I don't want to get into it too much. But the thing with water is water produces hydrogen bonds. These are very weak bonds, but they're relative to other like covalent bonds or whatever you want to call them. And these bonds, they attract water molecules to each other. But they're not attached to each other, they're just attracted to each other. So here's a water molecule, there's a water molecule. And it happens in places where air can touch the water, right? And this attraction keeps these molecules close together, but it doesn't completely bond them to each other. And this is what can create something called surface tension. And you've seen surface tension into play, like when you've been at the lake, right? This is water, by the way. And you've seen that bug that's able to walk on water, right? Well, the surface of the water has these hydrogen bonds on it, and so they're able to hold together when these little feet are spread out. They don't break. This is called surface tension. And water molecules do that. So these water molecules in here are going to be attracted to each other. And what water molecules tend to do, what water tends to do is it collapses bubbles. The surface tension collapses bubbles. Well, alveoli are very similar to bubbles. And so the tendency is to want to pull that together. They want to collapse that. And so you could cause your alveoli to collapse if you didn't have this surfactant. Well, guess what emphysema does? It destroys surfactant cells. What are these cells called? I wrote it down. Septal cells. Septal cells. Which makes sense because septal means wall. And so these cells are in the wall of the alveoli. So there's the alveoli. Now, real quick, we're going to talk about the thoracic cavity. Actually, it's one great big cavity that has multiple cavities inside of it. The thoracic cavity has pleural cavities. And each cavity contains a lung. Each pleural cavity contains a lung. So you have a right pleural cavity and a left one, right? Right and left. And we're going to draw that over here. Here's our chest. Now the walls of your thoracic cavity, the walls are made up of, you got your rib cage, right? So the thoracic cavity, you got your rib cage. You got your vertebrae. And then you got your sternum. And then you got your diaphragm. And that makes up your thoracic cavity. All right. So here we go. And inside, you're going to have your lungs, right? So here's your trachea coming down. It's going to branch. And there's your primary, right and left primary bronchi, and the left is going to branch twice because it's got 2 lobes, and your right is going to branch 3 times. It's got 3 lobes. Then those are going to branch all those different times, right? And then you have your lung. Your left lung has got that little notch in it, the cardiac notch. The thing about your lungs is that they're covered, we haven't done orange yet, I like orange. They're covered in what we call a pleural membrane. So each lung, and this is called the visceral pleura. Visceral means organ. And so this pleura is attached and kind of digs into the surface of the lung. It's called a visceral. Okay. We've also got the parietal pleura, which attaches to the inner wall of the thoracic cavity. It also attaches to the diaphragm. And that's your and what these do, now there's not this much space between them. There's a little bit of space, but not big like this. Each of these secretes pleural fluid, which acts as a lubricant. So that when you breathe and your lungs inflate and they come in contact with the parietal pleura and the visceral pleura, they come in contact with each other, this pleural fluid is a lubricant and reduces friction. It reduces friction. If a person doesn't create enough pleural fluid, you can get a condition called pleurisy. Pleurisy, and this is where you have it's very painful. Because what it is that there's a significant amount of friction between these two membranes. They start to stick. And that is painful and it's sharp. Oops. Sharp pain. And it's worse upon inspiration. That's kind of how we know about it. So there's the thoracic cavity. I didn't draw the visceral. Obviously, well, real quick. Obviously, we've got the heart in here. And then behind the heart, we have what we call the mediastinum. And this separates the pleural cavities. It also contains the major pulmonary vessels, actually pulmonary and cardiac vessels. So this would be like your pulmonary artery, right, or your aorta. This mediastinum, and this is kind of posterior to the heart, right? So the heart's actually in its own cavity. The mediastinum is posterior, so behind the heart. It also contains the esophagus, the trachea, and it kind of holds them in place. And that's just an important thing to know in terms of the structure. And so that would be immediately behind it. It's going to help keep all of this where it needs to be. All right, that is the conclusion of our airway anatomy. Let me know if this helps, if you like them. I'll see you in the next one.